Okay, it's fucking grind time. Let's get it. What was the last shit that I... Did I even fucking publish the last shit? I don't even remember. Yeah, I guess so. Why did this video go nuts? It's another comment? Is it something I didn't respond to or what? No comments. GG. Oh. This? Oh, hell nah. Man, let me learn, dude. Shit makes me nervous, bro. No, let me fucking cook on my own for a while, dude. Gotta max this shit out. I don't have time for anything else. No time. Alright. Yo, yo, yo. It's fucking stuck. Can we not? Good? We're good. KO. So last time, this is the chapter about type deduction. So I guess using the auto keyword later. When I was learning C++ for a second, using some stupid ass free LinkedIn learning shit that I had because of work. This guy had me using auto from the very beginning, saying that it's better than explicitly typing in the type for something. I mean, maybe it makes sense. I mean, if you created a bunch of what would that be, bro? It would have to only work for like integral and regular types, right? Like if you included the header file string and you did auto and then initialized value initialized it, so auto my string and then brace initialization and then a word, so the quotes, the double quote, and then just Ethan, my name or whatever is what it's called. And you had standard string included, what would the auto do standard string? What if you didn't include the string? What would auto do? What if you had we're doing random number shit and we're doing a Mersenne twister, or you're doing like, I feel like there's no way to, the only way you could, it's because the only way it can know is with the initialization value. So if you don't initialize an auto, maybe there was something about it being initialized properly later, but then that means you have a piece of memory that doesn't have a data type for a second until it gets initialized, which would be weird. Like, if we had it initialized as a string, and you included the string header file, and you gave it like Ethan as the name or something, as the string, as the characters, as the array of characters, I think. Well, it might automatically go and find, okay, standard string. But if I wanted to do a Mersenne twister, and instead of doing standard fucking scope resolution operator, Mersenne twister 19937 or whatever, instead of that shit, if we just did auto, I would have to give it an initialization value so that auto goes and finds and decides to use standard Mersenne twister, which would mean I would have to pass it, what, a seed sequence maybe? Because the only thing I know that a seed sequence can pass shit to is a Mersenne twister. I think it's an array. Excuse me. It's multiple pieces of information, because a seed sequence is like a sequence of unsigned integers, it seems like. And there are multiple different values that you can seed in a Mersenne twister. You don't necessarily have to pass it all of them. Like, I could seed a Mersenne twister with one, or I could pass it a seed sequence. Or maybe a seed sequence combines them. I'm not actually sure how a seed sequence works deeper. I just know that we initialize it with multiple, so comma separated integers, or at least unsigned integers, and we can then pass that seed sequence into a Mersenne twister to seed it and not underseed it, and then we can call it and get some cool values out, and then eventually use a uniform int distribution to get a value within a specific range, instead of dealing with this big ass number that spits out like a 32-bit or a 64-bit ungodly sized integer. Unsigned integer. Okay, doke. So last time we were learning about, so there was type shit. So there's auto. That's what I'll have to learn at some point. We have type conversion. So what happens when you pass when you pass information that is one type when the expected type is different. So if I pass um, an integer to a function that takes I pass as an argument an integer to a function that is expecting uint 16, an unsigned integer with 4 bytes. So it's probably 2 bytes actually. So 16 is smaller. Okay, that's the one that only goes up to like 16,000 or something like 60,000. I don't know. Doesn't matter. So we talked about numeric promotions, which is when the type conversion is increasing in the amount of memory that something gets. So we're converting it to a type that has more memory because the target type is more efficient. So if we're on a 32-bit operating system, so 4 bytes, and we have an int 16, so an int 16t, or int 16 underscore t, standard library, and I pass it as a parameter to a function that takes in, or I return it an int 16, but the return type is a regular int, so probably a 32-bit int. Type promotion is when that uint or that int 16 is then is basically, it seems like it's passed to some sort of function, some sort of internal process that spits out a different data type. It's been like a day because I was fucking hanging out with family because I was on a little vacation kind of thing, and I didn't spend as much time programming as I should have. I only got a few videos out, maybe like, I don't know, 3, 4, 5 hours ish, something like that. I'm trying to remember. So the values are represented differently depending on how much memory is allocated to a specific type, at least for some. So like the binary representation of a number inside an integer is different than the binary representation of a number within a float. So 3 as an integer is different than 3. So what is that? 1, 1 in binary for an integer is different than how the binary would represent it for a float for 3.0. So the compiler has to find out the target value that would make sense. So we're going from 3 to a float, so now we have to add a trailing 0, so 3.0, because floats are floating point numbers, so they have decimal point. So it adds the 0.0, and then it has to convert that value, so pass it, seems like, as an argument into a function that returns the target type, which is a float, and it takes that binary value and spits out the converted binary value. So it says, hey, your value is this, it needs to be this. So we got to convert u1 as a type, so when we return u to this final temporary object, you're the correct type, but 2, that you're the correct value as well. So we have to figure out what in binary it needs to become. Maybe it goes from whatever, a bunch of zeros, leading zeros, to finally 1, 1 for 3, and then finally it becomes fucking 0, 1, 1, 0, 1, 1, 1, 1, whatever the fuck 3 would be in a float. I have no idea in binary. So that would be numeric promotion whenever we are increasing the amount of memory for something. So if we're talking about like an int 16 to a float, that's probably a numeric promotion. If we're talking about a short or a uint 16 to a regular int, or an int 32, or an int 6, well, not an int 60, well, it depends. An int 64. If we're increasing the amount of memory in order to make it more efficient, we're cool. Actually, that was incorrect. I think it was a numeric, even smaller, an int 16 to a float should be a numeric conversion, I believe. And I'll refresh myself here in a second on that. And I think so, because it is not... It's like it's not the same. I'm seeing some crazy visual shit, dude. It's like some dark circular thing or something that's like approaching me and encompassing all of my vision. What the fuck is going on? It's like I'm some kind of learning entity. I don't know what's going on, bro. So if we took an int 16 and then passed it to finally return a regular int, so probably an int 32 or maybe an int 64, if the uint 32, or if the int 32 or int 64 is more efficient, so probably if it matches our operating system, so a 32-bit or a 64-bit operating system, then we're talking about numeric promotion. Taking the less efficient 16-bit integer and converting it to the 32-bit integer if I'm on a 32-bit operating system. And, or at least architecture that is more efficiently able to process 32-bit integers. And then same thing if it became a 64-bit integer instead, so uint 64, or sorry, an int 64. I keep saying uint whenever there's a number, but it's not. There can be no, it doesn't have to be a letter. It doesn't have to be unsigned, duh. But if we're in 64-bit architecture, or at least operating system, whatever, something like that, and we're taking a short or an int16 type conversion into an int64, an 8-bit integer, would be numeric promotion because we are converting it to a type that has more memory and is more efficient. And it's for the purpose of increasing the efficiency. A type conversion instead would be like a like a uint16 to an int16, or a uint32 to an int32. We have same amount of memory allocated to something, but we're just switching the sign. So it's all allocated to the positive versus it's allocated half and half to the positive and negative sign in the unsigned part. Or an integer into a float, numeric conversion, because we're not. It's almost like numeric promotion describes some things, and then in the numeric conversion describes what isn't numeric promotion if it's still in the realm of numeric shit. So if we were converting maybe a float to binary, or maybe an integer to binary, or binary to an integer, something like that. I think these would all be numeric conversions. So conversions that are done, like that int with the value 3 becoming 3.0 for a float, which would be a numeric conversion. So we're not just allocating more memory to something to yield the type that is more efficient. Float is a totally separate data type, and it's like a separate category of data types. So it's still integral. They're still integers. Actually, no, floats are not integral. Those are just characters, booleans, and integers. So it's a non-integral type, but it's an integer becoming a float, which is its own separate category. It's not, oh, we're going from an int16 to an int32. We're going to a whole separate. An int16 and an int64 are separate data types, but they're, I guess, categorically separate data types. A float versus an integer. So, at least in this case, an integral data type to a non-integral data type. They're both numeric. It's a numeric conversion. Okay. Fuck, maybe closing my eyes isn't the way. I feel like I'm gonna fucking fall asleep or something. Did I? Oh, are you kidding me? Just touch the fucking lens, dude. So annoying. Alright. Different types of numeric conversions. Okie doker. Let me see where I was last time. Oh yeah, there were safe and unsafe conversions. So safe conversions where the values get preserved. Okay, I think I'm just gonna go through all this again. How far did I get? I think I was on a warning. Yeah, I definitely wasn't here with this big ass fucking hex shit. Unless the LL, never mind, LL's long. It's either 2 lowercase or 2 uppercase. I think we were on this one here. Yeah, I saw this part. It can be reinterpreted. At least it seems like you can reconvert something if it's in the same line and it's safe. So if you convert an unsigned int to an int and it's safe, because we're talking about Actually, if we convert an int to an unsigned int, and the int value is 5, it's positive, it's unsigned, and we convert it into an unsigned int, we're cool. But usually if we pass it, well, what would be a better example? An unsigned int to an int, and then an int back? Yeah, so you could pass an unsigned int to an int, and it's probably okay as long as it's not too damn large. But then the worry is passing from an unsigned, or converting an int to an unsigned int, because then if it's a negative value, then we're fucked. So the only issue with an unsigned int to an int is just overflow. So I need to eat more meat or something. My breathing's kind of whack again, and it's probably sleep that too. I'm gonna eat some chicken during the break, I think. Ooh, fuck. But the worry there is after we've converted the unsigned int to an int, and then we're converting back from an int to an unsigned int, you'd think that there would be an error for, or at least a warning from converting an integer to an unsigned int, because it could be unsigned. And then we get wraparound and we're kind of screwy. Well, I guess either way, wraparound is the issue. It's either too large to be an int, or it's too small, meaning too negative to be an unsigned int. But at least here, it looked like if it's in the same line, so if we're converting something to something, and we're converting it back, so if we're saying, hey, static cast this integer to an unsigned int, or this unsigned int to an integer, and static cast the return type of that from an int to an unsigned int, it's actually okay, because it started out as an unsigned int to an int, but then is going back from an unsigned, or from an int to an unsigned int. The start type is the same as target type. We converted it once and it was okay, but then we have an unsafe conversion, but it's okay because it's a conversion back to what it already was. I don't know if it has to be the same value or if it just has to be the same range. Like if the start value and the end value have to be identical for it to not be weird? Or not, but I'll find out. Alright, so. Oh, shit feels weird. I'm on this computer again, damn. Alright. Yep, narrower types to wider ones. Cool, more efficiently. Yeah, like promoting a float to a double. Yep. If double, well, yeah, because doubles are apparently the default when you do when you pass 0.1 into something as a literal, it's a double. It's not a float. At least in a normal operating system. I'm on just regular ass Windows, which might have to change at some point. I might have to use like some shit that goes Linux mode, so I can do some command line interface stuff maybe. Yeah, that makes sense. So if we're talking, there's floating point and there's integral promotion. So there are promotions within integral values, like a character to a short. A character is a 1 byte integer, whereas and that's because they only go up to, it seems like maximum of 127. So that's the highest that a 1 byte guy can go to, seems like, right? Because I think it's 64 and then 128, something, or 64, and then everything else adds up to 63. And then 0 is unsigned, so it's positive, so 128 total values. Okie doke. So we have the integrals as they go up, so going from a short to an int32, or an int32 to an int64, if the int64 is more efficient for your system. Things like that. Same thing from a float, that's probably always reinterpreted as a double via the type conversion, good old stuff. Specifically, float promotion. Or floating point promotion, I guess we say, not float. Integral type to other integral types. So between characters and integers and booleans. Oh, and unsigned guys. Okay. Or ones that aren't more efficient. So a long is not the default type for an integer. A double, it's like, to me in my mind, it feels like a long to an int is a double to a float. But in reality, a double is more like, it's just the most efficient thing, it seems like, for a floating point value. So it's more like a short to an int. So shorts just get converted up to ints naturally. It's integral promotion, just like a float gets promoted up to a double. Oh, back to the yawning. Here it is. It's so stupid. All right. Yeah, excluding the promotion. So we're not talking about a short to an int. In this case, we're talking about an int to a short. So we're passing an int to something, a short to a character. So we're going shorter, an int to an unsigned int. So same amount of memory, not getting more efficient. It's not numeric promotion. It is what it is. Floating points to other floating points. So double to a float, or a long double, or a double to a long double. So sure, double may be the most efficient, but a long double is not more efficient. So it's not numeric promotion, it's instead conversion, numeric conversion. Yeah, floats to integrals, integrals to floats. It seems like it's just the whole movement of these integral types between each other. Okie doke. Floats. Fucking unsigned ints. You got fucking all these guys. And we're talking, apparently when we usually say integral type, we're not talking characters and booleans. But okay. There's those. There's between integers and floats. There's between floats and inefficient floats. So a double to a long double. A long double to, well, yeah, fuck it. A long double to a double. A float to a long double, etc. Between booleans, between characters, I think that's about it. So we got the floats, floating point values, and integers. Oh, well, vice versa. Yeah. So there's floats to integers, floating point values to non-floating point values to integral floating point to integers, integers to floating points and integers to booleans, maybe even the vice versa. Floating points, or let's see, integers to each other in non-integral promotion manner. And then floating type to any other floating type. Am I getting fucking retarded? What am I saying? Do I just need meat or something? Do I just need food? I'm gonna do some push-ups. What the fuck am I doing, bro? What's happening to me right now? I have my chicken. The second my chicken defrosts, I'm good to go. I'm gonna turn the water on for it so it defrosts faster. I have no clue. Guess I'm dying or something. GG. 1, 2, 4, 5, 6, 7, 8. Easy enough. Don't want to go too crazy. I still want to be able to think. Okay, Joker. So, shit that's not fucking more efficient. Between floats and each other, integral values to floating point values to integral values, between the integral values, so between integers and booleans and characters, and then fucking floats to bools. Whatever. We're talking about integral types. I'm using it by the definition. If we're including characters as integral types, then we also have to include booleans as integral types. Because all three are part of the same family. We're not going to say that these two are part of it and this guy's not. This motherfucker is still in the mix, even if he's a little estranged because he's only 0 to 1. But this guy's only 0 to 127. So group them together. Fuck it. Ah, makes sense. Yeah, yeah. We're gonna use copy initialization for these kind of tests because if we're initializing a long double as a double, oh, sorry, a double with a long double value, which I guess you would get by just having enough precision to it. You just have enough freaking decimal places in the number, in the floating point number. Okay, that's too much water going on right now. Okay. So for initializing a float with a double, or a double with a long double, we're going to get a narrowing conversion if we use brace initialization because that's the safe way of initializing things, apparently, according to current knowledge. So it prevents loss of data. So loss of precision, losing, getting rounding errors, taking a float and converting it into an integer. But now we're losing data, we're losing those decimal points. So no brace initialization here. We're going to use copy initialization, yo. The equals sign, the assignment operator. Safe and unsafe conversions, yeah, so these are when you're converting from a type to a type that can already hold all the values that it's given. Numeric promotions are always good because we're always going from a 2-byte unsigned int, so a uint16 to a uint32. A uint32 can hold all values of uint16. It has more memory for the unsigned part and more memory for the signed part. It's got more for the positives and the negatives. It can hold the entire uint16 inside it. Many numerics are unsafe. Yeah, I mean, fuck it. You have an integer that's 3 and you're going to Boolean. That's 1 now. Okay, I mean, it's the same result, but it's fine. But you're technically losing data. You're losing the 3. Yeah, let's just see. Let's just fuck around and see how this shit works. So we have, oops. Let's do bull thing thang, and we'll just say 3. Okay. Bump. Data loss of bucko. Let's try some floating point shit. Oops. Okie doker. So we'll say float big ol' thing. And then we're gonna do 3 point fucking huge number. Uh-oh. Same shit, maybe? Oh. Truncation from double? Really? What if we do even bigger? Fuck. What if we do even larger, huh? Damn. Still always says double because I guess it's still a long double. But the issue is different. It's truncation, not narrowing conversion. Guess I'll learn that at some point. And it seems like truncate is when we're cutting shit off. So maybe it is a different process. Like, no, because the narrowing conversion is for 3.0 to 3. Or 3.1 to 3. Actually, sorry, for an integer, or a float to an integer, I thought it was truncation. Where we are cutting off the end and we're just losing it. What if we try? Okay, narrowing conversion versus truncation for other stuff. Okay, dope. At least one value of the source type, so the initial type, can't be converted into an equal. At least one. Meaning, so, an integer into an unsigned integer. There we go. Value preserving, so an unsigned int 8. So a 1 byte unsigned int. which means that we have one whole byte, not half, so one entire byte, 8 individual bits. It goes all the way up to 257. So, or two, right? So it's 128 plus one less than that. So it's, oh, 255. Sorry, I added the wrong way. I'm retarded. My bad. Oh, 255. That sounds a lot more correct. Can be held completely within an int 16. So it's double the memory in both spots. So even though we have large memory on one side, the next bigger guy doubles, so he can hold all the positives now, and he can hold negatives that unsigned ints don't even have. So like a short to or an unsigned short maybe, or a uint a uint 16 into a regular integer, an int 32. Good to go. Safe. Unsafe is where at least one value cannot. Okay, so that would be value preserving, where we have a short to well, that's a promotion, but an unsigned uint 16 to an int, value preserving. Or int to long, because it's big to too big, or short to double. Are you sure? Oh, short to double, because we're not going more efficient, we're getting bigger, and we're going to, I missed this. Yeah. So we have a short, which is 5. So we have an integer. Wait, really? What happens if we have an int and then we initialize a short with it? Oh, error in conversion, because the memory has already been allocated. But so it's okay to do that. So maybe 5 is already treated as a short when you make it a literal. Because otherwise, like if we do 3.0 to initialize, we do the literal double to initialize an int, we get an error in conversion. So the literal is by default. The literal 3.0 is a double. The literal 5, I don't think is an integer, because then that's a 4-byte guy, at least on my architecture probably. Or for sure it is. And if we're initializing a 2-byte guy, so 4-byte, sorry, I think I said bit. We're initializing a 2-byte guy with a 4-byte guy, we get an error in conversion, we get a loss of data. Well, but the bits are the same, so maybe we actually don't. We're not dropping a decimal place. My question was just here, initializing the short with 5. So either this guy, his size is determined. Maybe because he's small enough, he's just a short. Okay, sorry. But in this case, the main points are taking an int, making it bigger, but not more efficient. Same thing with a short, and we're going double. So we're making it have more memory actually, but we're changing the type. We're not staying within the integers, we're not staying within the floating points, we're actually going from an integral value into a floating point value. We're increasing the memory. But it's negligent, it doesn't matter. This would be the same if there was a smaller double, smaller version of a floating point value that's smaller than a float. And we're initializing it with a short. Same shit. And in that same case, it should still be able to hold all the different values here. So value preserving conversion. So it knows that, hey, this guy's going from an int to a long. It's okay. It's value preserving. Even though he's passing an int as an argument into a long or into function as a parameter that's long, int to long, it's okay. No data loss. Converted using a value preserving conversion can always be converted back. So if we go from a short to a long, at least in the same line, we can go back from a long to a short. And it's because we're using the same value. So we're converting value to value. We're just passing the potatoes between the hands. We pass it from Jimmy to Johnny. Johnny can pass it back to Jimmy. But if Jimmy passes it to Johnny and then Johnny goes back to sleep, well, if it's the same value, then maybe it's okay. So we could go from, well, let's find out. Is it that it has to be the same line? So it's the only, each time the value is used, the compiler's instruction, the whole line, has to get the value back. Or is it literally just the same value? So if we take this, I open up a fridge and I take the meat and it's in a cold fridge and I put it over into the warm, because it's okay to go from cold to warm. Warm is kind of sketchy to go from warm to cold. Normally there's a warning. We don't want to, well, it should be the other way, but whatever. Normally we don't want to cool our hot shit, but because it started in the cool and it went to hot, it's okay. So in this case, my investigation will be two variables. One is an integer, one is a long. An integer to a long is a safe value preserving conversion type data numeric conversion, but a long to an integer is not. So if it's okay when I do it in one line, is it okay when I do it in two lines? Meaning that if I say, hey, x is an int and y is a long, and y is initialized to be x, okay, the long is initialized to be an int, can I then later on say, hey, x is now y? Is this the same values? I don't know. So if we say yeah, there's an Aryan conversion when we make this guy unnamed. But if we instead say int x, oh, are we doing, we're doing copy initialization here. Oh, isn't the reason just because of the fit? So if we say there's an unsigned int and it has a value that can fit within an integer, well then that same value, if it was allowed to pass through one way, it can be passed the other way. I'm not gonna, if I passed in a negative number from an int into an unsigned int, that is an unsafe conversion. Therefore, when I pass that value back to the int, it's going to be different. It's probably going to overflow, or it's going to be positive or something. If I pass in -1, it's going to be this big ass unsigned int version. And then if I pass that big ass number back to the int, well, the int's probably going to be +1 because it counted all the way up and couldn't fit. Oh, sorry. Actually, it's going to be negative. It's actually going to be the negative, whatever the maximum shit is. Okay. Now I understand. It's just because if one value is preserved in one way, then it is preserved the other way. If we pass in 4 as an unsigned int to an integer, it was value yeah, if we pass it, whatever, either way, if we pass in 4 from an int to an unsigned int, it's value preserved because 4 can be contained in an unsigned int, and then I can convert 4 back to being an int without having changed it before, and we're golden because it passed through one way, so it can pass back through. It's not going to magically overflow all of a sudden once it gets passed backwards. It's good. But if I passed in a negative number, then we're going to get some wraparound action. So -3 for an unsigned int will be whatever, 2 less than whatever the maximum value is. And if I pass that back, so it was unsafe one way, and if I pass it back to being an integer, well, now it's too big. It doesn't fit within the integer, so now it's unsafe again. So if it's safe, it's safe. If it's unsafe, it's unsafe. Unless we manipulate it between. So if we say, oh, we passed -1 to be an unsigned int, but then we fucking add in, we pass in -1, but then we add 1 to get it back to 1, and then we pass something else, then we're cool. Meaning, if I pass -1 to an unsigned int, we get some wraparound. So if I passed it back, we'd be fucked because the int can't fit the entire positive side of an unsigned int. But if I add 1 to the unsigned int to bring it back through wraparound to be just 1, oh, well, 1 fits in an int, a regular int, so we can pass it from an unsigned int. So if it goes one way, it goes the other way. It goes both ways. Cool. Gotcha. That makes sense. A value. It's not the whole, oh, this literal number here in the same instruction has been. It's not that. It's just the value of the value. If it's safe one way, it's safe the other way. If we pass 0 or 1 from a boolean to be an integer, okay, integer could be passing 2 or 3 back or something and be huge back to a boolean, and then maybe we have, it's not going to be an issue, but maybe technically there's a narrowing conversion. Well, if we pass it the value, and then we don't use brace initialization because that'll give us just a warning, the value will be okay in the end. It'll get us the same shit. But if we pass 1 to an integer, but then we pass the integer back, brace initialization will say, hey, whoa, you're initializing a boolean with an integer. But the value will be the same because the value was okay in one path and it was okay in the other. You have booked your flight. You are okay to come back because you booked the round trip. You don't just book one flight and then the value has to come back a different way, or when it comes back it's different. It's the same. 5 leaves from unsigned int to int, unsigned int back to int, or int back to unsigned int, comes back as 5 unless we fuck with it. So as long as we do it and we don't fuck with it, it's okay to come back. Okay. So we're casting 3, which is an integer, to be long, so we're making it bigger. So in this case, it's not numeric promotion because a long is not more efficient than an int. So we've made it bigger, but then we're casting, that long's return value, the result, to be an integer. Well, 3 was okay to go to a long without any wraparound or anything, and now it's okay to go back. Just like here, if we cast C, which is some character integer number, probably whatever, 97 plus 26 or something plus 2. Was it like 130? Some fucking number. I don't know what the actual conversion is. I think it's 123 plus 3, or plus 2, 125 maybe. So let's just say it's 125. We're taking 125 and making it a double. Okay, doubles can hold all of 125. It'll just say 125.0. But then if we cast the double 125.0 to be a character, oh, it's okay. Characters can hold up to 125. It'll just drop the end part because this is copy initialization. So brace might have an issue, but it's like we send a message to the spies, but the guy's reliable. Other people might say, hey, no. We are the braces. You sent a message to him, don't expect to get anything good back. But me, I've known the guy for a while. He's good and he's reliable. I send him the message, I know I'm going to get the same shit back. We're good to go. Cool. Reinterpretive are unsafe or maybe different, but no data is lost. So signed and unsigned, meaning that there's the same amount of memory. It's just that there's some sort of wraparound going on. Unsafe, so the values are different, but no data is lost. Meaning that we're not dropping a bit. We're just saying, hey, we passed -1 to an unsigned int. Now it's fucking 3.4 billion. 3.15 or 6.3, I don't remember. Something like that. 1.3? 2.6? I don't know. Something, I don't remember the numbers. So it's a fucking 2.3 billion minus 1. If we pass it back, oh, well, we're passing this big ass number now to an integer. So integer's gonna go all the way up, and then it's gonna count. It's gonna pass, wrap around all the way down from the tippy top down to the bottom, and then it's gonna count all the way up, and then we'll probably get something like a 1 out. So we passed in -1, and then we get out some crazy number. Well, not crazy in that case, maybe. Oh fuck, I'm sleepy. Oh yeah, I forgot. I didn't even get 6 hours of sleep because I flew in too late. Got here 7 hours later, and then I fucking ate some food, got all my shit packed away, and that took too long. And then it was like 5 hours and 50 minutes to go to sleep. Okay. I might take a longer break today. I'm just gonna do this, and then I'm gonna eat a bunch of food and recoup, and then we'll go back. So it might not be a whole hour and a half self-test. Gotta get this info back in the brain real quick, and then I'll test myself on it. Reinterpretive conversions, unsafe. Yep, so no data loss. We're not dropping bits. The values might be different. Okay, so we have 5. Yes, so these are unsafe. We don't necessarily want to do them. We have 5 as an integer. Pass them to unsigned int. It's okay. It's okay. It's a freaking value preserving conversion. We're good. Unsigned int can hold all the int shit if it's positive. But now we have another int that's negative. Unsigned ints can't hold negative shit. So same amount of memory, so we're cool. 4 bytes likely. But now we're going to get 4 less than the maximum value of an unsigned 4-byte integer. So we're going to get some fucking long ass shit. And the thing here is that we're not getting -5 on this end. So we're sending a message, and it is different on the other side. Value preserving, we send a message, it's the same. He sends the message, and it's the same. Value non-value preserving, or reinterpretive. Send a message. Ooh, the message is different. Therefore, when it gets sent back, ooh, it's going to be different. I tell him, hey! And then he fucking yells back something else. And I did not hear what I fucking sent, buddy. We're cool as long as they can hear each other. This guy can't hear this guy. -5? That ain't fitting, yo. Yep. Wonder if binary is the same for unsigned ints. I think so. Yeah, it has to be because we were doing that with bit set. No, we weren't because yes, we were. No, we weren't. Maybe. Not really. We're treating them as individual bits. Yep. Yep. And their implementation defined because what we're converting it to might be subject to, well, we're converting it to the same type. The value could be different. If we're converting a negative fucking integer or a negative short or whatever to an unsigned int, well, we don't necessarily know if the unsigned int is, let me see. Yeah, we don't necessarily know if an unsigned int is an unsigned int 32 or an unsigned int 64, or probably not a 16 because that's really small. It's one of those. Which one? If we pass in a negative value, we're getting the maximum value of a uint 32. Or could be the maximum value of the fucking uint 64. And those are incomparable. Makes sense that it's implementation defined, yep. Seems like static cast does does some, or actually no, that's fine. Static cast just seems like it's the function. Oh yeah, I guess it is, huh? Some sort of template shit we're passing in. Hey, here's the type that you need to make this guy. Here's the value. And then you figure out the rest, buddy boy. We know that it's coming out this way, but you figure out the value. And then it does. Standard library arrays, and that's because, oh, hey, we just say -1 or -2 to get the last thing or the second to last thing within an array. Instead of having to say, oh, there's fucking 4,000 things in the array, and we want to have some sort of algorithm that gets the last one and pops it in the front. And all we do is every time we just grab the -1 and then put it in the front. Oh, and we grab the -1 again and we put it in the front. But instead, if we turned off the implicit type conversion, where arrays have this unsigned int guy, because we pass it -1, it well, I guess it modular wraps is what you say because it involves the negative shit. It goes to the maximum guy. So -1 is actually the largest one possible because 0, 0, and if we go down 1, oh, unsigned ints can't go down 1, so they go around 1, and they're at the end. So array, the data type of an array's index or indices is an unsigned int of some sort of memory that we don't know. With 32. So if that's hard to avoid, then we have to be careful. But my shit has warnings treat warnings as errors enabled, so we do get the errors or the warnings. Oh, I gotta do my dry laundry in a minute. I'll go 5 more minutes and then I'm gonna eat. Oh, in the majority, because, well, Oh, because normally we're talking about passing a regular ass number there. So like when we're accessing elements of an array, we're probably or element fifth element. Maybe it is element, not the index. No, it's gotta be the index for sure. If we access the fifth index of an array using an integer, well, 5 and 5, yo. 5 is an int and just 5 is an unsigned int. Value preserving, yo. We're chilling. We're good to go. We have a safe conversion. So most of the time we're probably using positive shit that fits within an unsigned int. So we're good. We're not using negative numbers anyway. So most of those conversions don't change the value. But it's when we use negative stuff that the value changes, and maybe there are issues. But I have warnings as errors enabled, so it's fine. Yeah, spurious warnings because, yo, 5 converted to 5, bro. There's no fucking change, but now it has an issue of int x is this, unsigned int y is fucking x. Woohoo! Narrowing conversion potentially because of the negative. Which means the warnings are spurious. Yes, they're unnecessary, they're incorrect, they're not needed, they're illegitimate. Be careful of inadvertent conversions. Yep. Yeah, you fucking attack the enemy, and the enemy has some sort of resistance, and the damage is oh. Yeah, that wouldn't be. That'd be funny though. Oh, maybe that's probably a thing that someone accidentally had in the game at some point. If you well, let's see. If you do too much damage to something, and you're converting an integer to health, that's an unsigned int because you can't have negative health. Well, you did too much damage, and your over damage heals it because it can't die. Well, actually, yeah, because you have to hit it to exactly 0. If you hit it lower, then it actually just counts down past 0 from the highest number. But if you do damage to something and then it subtracts 1 or something like that. Let's see. Yeah, if you're going to do 1 damage to the guy and he has an automatic damage, or oh yeah, so if you have an integer damage, let's see. I don't know, yeah. So if you can't do negative damage to something, yeah, you need to check to make sure that it's 0. So basically, here's the thing. Character attacks using unsigned int damage. Enemy has damage resistance, and it's a flat subtraction, whatever, of a literal. And it subtracts 3. Well, if you're only going to do 2 damage, and you subtract 3 from it, you get -1. But remember, damage is an unsigned int. So it's not -1, it's actually the largest possible. And then instead of doing 0 damage, no damage at all to the enemy because you only did a little bit of damage, and he had damage resistance or some sort of effect that reduced the amount of damage he took. He was blocking or something like that or whatever, in like Pokemon or something. Take half damage on the next attack, like defending, whatever. Well, or, maybe Baldur's Gate, for example. Actually, I think that just increases your AC. I can't remember though. It wasn't super great. So, you subtracted that number. Well, you get wraparound. You go from -1 damage, which isn't holdable by an unsigned int, to 1.3 billion damage. Then, guys kaput, dead. I'm gonna pause now and I'm gonna eat because I need food, I think.